So in this video looking at surds, we'll be focusing on how to rationalize the denominator. So a rational number is a number that cannot be represented as a fraction. So an example of rational numbers are square roots of non-squared numbers. So for example, root 3, root 14, root 10, or even pi. So the expression of rationalizing a denominator is basically asking you to find an equivalent fraction whereby you do not have a square root or a surd in the denominator. A surd or a square root in the numerator is, however, absolutely fine, hence the term of rationalizing the denominator. Now, the actual method of rationalizing the denominator is quite a simple one. Now, the general method of rationalizing the denominator is to multiply both the numerator and the denominator in the fraction by the denominator. Now, if you do have two terms in the denominator, then all you need to do there is just reverse the sign that's in between the two terms. So, for example, if that makes absolute zero sense to you, then do not worry. So for example, if I had a fraction of 2 over root 3, then here I've only got one term in the denominator, which is root 3. And what I'm going to do is I'm going to multiply this by the denominator, both the numerator and the denominator, or top number and the bottom number, by root 3. And then I can then work it out as normal. Now, the key thing to remember is that when you are working with equivalent fractions, we're not actually changing the value of the fraction, because technically speaking, what this is here is I'm just multiplying by 1, because 5 divided by 5 is 1, 10 divided by 10 is 1, and root 3 over root 3, because they're both the same, is also going to equal 1. So technically, I am not changing the value of the fraction, I'm just merely writing it in a different way. I'm just giving it as an equivalent fraction, so to say. Now, if you're not too sure about what the blue bit represents in terms of what happens if there are two terms, well, that basically means if I had 2 plus root 5, and let's say I had 3 plus root 7, let's say. So here you can see I've got two terms in my denominator. So here what I'm going to do is I'm going to multiply both the top and the bottom by the two terms. So 3 root 7, 3 root 7. But because there is a plus in between the two terms in the denominator, I'm just going to reverse it by using the opposite. So here if I had, let's say, 5 minus root 2, and here I had, let's say, root 3 plus 5, well, let's go for minus 5 because I had a plus before, and change that to a minus. Then what I would do is I'd multiply both the top and the bottom by root 3 plus 5 and root 3 plus 5, and then I would then go on to work this through. Now obviously, before we move on, it's really important that you are comfortable with multiplying with surds and know how it all works. But like I said, it involves and goes on to simplifying, and this is probably the last sort of part of surds that you're going to need, particularly at GCSE level. So it's kind of amalgamating and joining all the previous things you know about surds to combine it into one big final question. So let's have a look at some example questions. Now in this particular question, now questions are slightly worded differently, but this one's particularly nice. And the reason why is because it literally tells you what we're doing. So here we need to rationalize the denominator and simplify 16 over root 2. So starting off with the question, I've got 16 over root 2. So what I'm going to do is I'm going to multiply. I've only got one term as the denominator, so I'm just simply going to multiply both the top and the bottom by the denominator. So working this through, I've then got 16 times root 2. So a number multiplied by a surd, I just join them together because I can't simplify the two. However, a surd times a surd, well, all I need to do there is just multiply the two numbers inside the surds together. So that gives me root 4. Then simplifying that, well, there's not much I can simplify on the top, so that's just can still remain 16 over root 2. But I can simplify root 4 because that gives me the answer of 2. Now from this, what I can now do is simplify the numbers outside. So here I can simplify 16 and 2, so divide both numbers by 2, in which I get my final answer of 8 root 2, and there is my final answer. Now it's always good practice for you to always check, can I simplify the number inside the surd? In this case, no, you can't. If it's a prime number, then that's pretty much it. It's usually a good standing point, but again, there'll be a previous video on how we actually go on to simplify surds. So moving on to the next question, again, relatively similar, just with different numbers, but again, it emphasizes the fact that I need to rationalize the denominator. So here I've got 6 over root 3. So here I'm going to multiply both the top and the bottom by the denominator. So here I'm going to multiply by root 3. So 6 times root 3 is just 6 root 3. And root 3 times root 3, well, a surd times a surd, I can just multiply the numbers inside, and that's going to give me root 9. So that leaves me with 6 root 3 over, because I can't simplify that, but I can simplify the root 9, which leaves me with 3. And then from this, I can simplify the numbers outside, and so divide both numbers by 3, so that's going to be 2 and 1, leaving me with the answer of 2 root 3. And there is my final answer. Now, obviously, I've left out the 1 because divided by 1 is just itself. So moving on to the next question. So here we've got something that's attached to the surd, but again, it still counts as one term. So here I've got 10 over 3 root 5. So again, I'm going to multiply both the top and the bottom by the denominator. So I've got 3 root 5. And then multiplying this out, well, I can only multiply numbers with numbers. So 10 times 3 is 30. And I've just got the 1 surd, which is root 5. Now the next thing I've got is I've got 3 times 3, which is 9. So let's use a different pen because that one's a bit rubbish. So 3 times 3, which is 9. And root 5 times root 5 is root 25. Now, from this, I could go on to simplify. So I can simplify the 30 and the 9, but I'm actually going to focus on more this, of simplifying this surd here. So root 25 is just 5. So what this then becomes is 30 root 5 over 9 times 5, which then gives me 30 over 5 over 45. So you can see here that I've automatically rationalized the denominator because I no longer have a square root in the denominator. But what I now need to do is simplify. So here, what number goes into both 30 and 45? Well, that's going to be 15. So that's going to be, how many 15s go into 30? That's going to be 2. How many go into 45? That's going to be 3, leaving me with a final answer of 2 root 5 over 3. Now, although I still have a fraction, because obviously in the previous example I didn't have a fraction, just left up as a normal term. However, here the question's just asking me just to rationalize denominator. So all I want is I don't want a surd or a square root in the denominator. Doesn't matter what the numerator looks like, it can be ridiculously messy, doesn't make a difference. All I want is this bottom number to not be a surd or a square root, and there is my final answer. So let's look at another example. So here we have got two terms in our denominator. So let's have a look at what we do here. So again, I've got root 3 plus 1 over root 3 minus 1. So here I'm going to multiply both the top and the bottom by the denominator, but because I've got a sign here, I'm going to reverse it. And so I've got root 3 plus 1. Now you need to make sure that when you've got this, that these two, the numerator and the denominator, is exactly the same. Otherwise, you will actually change the value of the fraction. So working through this, what I'm going to do is I'm going to incorporate some double brackets. So I've got root 3 plus 1, and I've got root 3 plus 1, all over root 3 minus 1 and root 3 plus 1. Now, again, we're not bothered about the top and the numerator. Now, again, one thing you might notice is the fact that we've got two things here. So I could write this as root 3 plus 1 squared, which is absolutely fine because all we're focusing on is that bottom denominator. Now here, going through my loops, I've got root 3 times root 3, which is root 9. I've got root 3 times positive 1, which is plus 1 root 3. I've then got minus 1 times root 3, which is minus 1 root 3. And then I've got minus 1 times positive 1, which is minus 1. Now, focusing on purely on this denominator, what that then becomes is root 3 plus 1 squared. That's the numerator, because I can't forget about that. Well, root 9 is 3. Now, root 3 minus 1 root 3 are just going to cancel each other out. And this is one of the reasons why we have a plus and a minus, because obviously it then incorporates dots, or difference of two squares, if you've looked at or know that topic. So that then disappears. So the only thing that I've got left are these two things here. So I've got to take away the 1. So then from this, because I'm running that space, I've got root 3 plus 1 squared over 3 take away 1, which is 2. And there is my final answer. Now, if you wanted to expand the brackets on the numerator, well, then that would be absolutely fine. So I've got root 3 plus 1 times root 3 plus 1. which leaves me with root 9 plus 2 root 3 plus 1. That is a 3. So that leaves me with 3 plus 2 root 3 plus 1, which leaves me with 4 plus 2 root 3. So if I wanted to, what I could easily do is in this final answer, which I've got here, I could write that as 4 plus 2 root 3 over 2. And then from this, what I can then do is actually go on to simplify this, because I can cancel the 2's out. So here that's going to leave me with 2, 1 and 1. And that then leaves me with 2 plus root 3. And there is my final answer. Personally, I would probably ditch this answer and actually go on to expand the bracket, so you do get a much simplified answer of 2 plus root 3. So moving on to a very similar question. Now this one's taken actually from an A-level exam, which is written slightly different. But you can see here that although it doesn't say rationalize the denominator, it kind of implies it in the question. So here we've got a fraction with a surd in the denominator, and we need to write it where it's no longer a fraction. Now in this, what we need to do is find the values of m and n. So this is how we want the answer to look like. We want it to look like something plus something root 5. And that's what we want. So from this, what we're going to do is we've got 7 plus root 5. So I'm just going to write out the question again. And so what I'm then going to do is I'm going to multiply this by the denominator, reversing the sign. So I've got 3 minus root 5 over 3 minus root 5. And that then becomes 7 plus root 5, 3 minus root 5 over 3 plus root 5, and 3 minus root 5. Now again, if you're not comfortable with working with double brackets and surds, there's another video which goes through how we actually do this. But it's virtually exactly the same as when we're dealing with algebra. So 3 times 7 is 21. And then we've got 7 times minus root 5, which is minus 7 root 5. And then I've got root 5 times 3, so that's going to be plus 3 root 5. And I've got root 5 times root 5 and a minus, so it's minus root 25. And that's all going to be over, and then expanding the bottom, I've got 3 times 3, which is 9, and then I've got minus 3 root 5 plus 3 root 5 minus root 25. Now going on to simplifying all of this, let's just go for another pen. So here I've got 21. I've got 7 root 5 plus 3 root 5, which is minus 4 root 5. And I've got root 25, which is just 5. And then simplifying the denominator, these two things cancel. So I'm left with 9 minus, and then root 25 is just 5. Now from this, if I just go on to simplify both the top and the bottom, I've got 21 take away 5, which is going to leave me with 16. And then minus 4 root 5, and that is being divided by 9 take away 5, which is 4. Now, so here I've got this. Now what I've got to do is simplify. So I can cancel the numbers. There's a number that goes into both all of these. So I can cancel by 4. And so what that then leaves me with is 4 minus 1 root 5. Now comparing this to my blue box in the question, then I've got m plus n root 5. So here, what I've got is to find a pen that works. So here we've got m equals 4 and n equals minus 1. And there are my two values if it asks me to. But the question doesn't say to specify m and n. So all I would have to do is just write my final answer like this, or I could write it as 4 minus root 5, because anything multiplied by 1 is just itself. So moving on to a very similar question. So again, along the same lines, let me just move it slightly up. So we've got a bit more space. So here we've got 1 minus 5 root 5 over 3 plus root 5. So again, I'm going to write it in the form of this. It seems like a very, very similar question. Let's check it's not, make sure it is the same. And it isn't, it's just slightly different, same denominator. So again, what I'm going to do is I'm going to multiply this by 3 minus root 5 over 3 minus root 5. Let's just move that up so I've got a bit more space. There we go. So looking at this, now it's really important that you do write this. This would actually be worth 1 mark in your exam. So even if I didn't go any further, then I would get a mark for just doing that. So here I've got 1 minus 5 root 5, brackets, I've got 3 minus root 5, and then under bottom I've got 3 plus root 5, and I've got 3 minus root 5. So working with the numerator, I've got 3 times 1, which is 3. 1 times minus 5, root 5 shall I say, is minus 1 root 5. Then I've got 5 root 5 times 3, which is minus 15 root 5. And then minus 5 times minus root 5 multiplied by minus 5 is going to give me positive, and it's going to be 5 root 25 over, and then multiplying the numerator out, I've got 9 minus, sorry, plus, nope, it's going to be minus, I've got minus 3 root 5 plus 3 root 5 minus root 25. So again, going on to simplifying both the top and the bottom. So here, now this is probably the one that I need to be careful of, because that's 5 times root 25, which is the same as 5 times 5, which is just 25. So what I've got is I've got 3 minus 16 root 5 plus 25. And that's all over. These two things cancel. That's a 5, so it's going to be 9 minus 5. And then from this, I've got 3 plus 25, which is 28, minus 16 root 5, and that's all being divided by 4. Now from this, I can then divide everything by 4. So that becomes a 1, that becomes a 4, and that becomes a 7, leaving me with my final answer of 7 minus 4 root 5, and there is my final answer. And if I wanted to, again, I've got m equals 7 and n equals minus 4. And there you go. Now we'll put some questions and along with their answers in the description below for you to practice how to rationalise the denominator.